Example on equivalence relation. We know that Z is equal to set of all integers which contain an elements say like -3, -2, -1, 0, 1, 2, 3. Okay. Now, for any AB belongs to Z, define A related to B if and only if A minus B is an even integer, check whether R is an equivalence relation. So, we want to check whether it is an equivalence relation and also determine its equivalence classes, distinct equivalence classes. Okay. So, now what is given here? There exists a relation between any two integer A and B if and only if A related to B if and only if A minus B is an even, integer. So, when we said a number is a even, if it is multiple of 2, then we can say that it is an even integer. Now, to check whether it is an equivalence relation or not, we want to check whether given relation is reflexive, symmetric and transitive. So, for reflexive, we know that since A minus A is equal to 0 and 0 is an equivalence relation, okay, and therefore, A related to A for every A belongs to a set of integers. Okay. Since for every A belongs to A minus A is 0 and 0 is an even integer, and therefore, given relation is, and therefore, this implies R is reflexive relation. Now, next symmetric. Now, if A related to B for any integers A and B belongs to Z, then this implies A minus B is even. Now, this implies A minus B is equal to twice K for some K belongs to Z. Now, if you multiply by minus sign from both sides, or if you take the minus sign outside from the LHS, you will get minus of B minus A is equal to twice K, and if you multiply this minus sign to right hand side, then B minus A is equal to 2 times minus K, and therefore, this implies B minus A is also multiple of 2, and therefore, B minus A is an even integer, and therefore, this implies B related to A, and therefore, this implies R is symmetric relation. Now, we want to check whether it is an transitive relation. So, now for transitive relation, now suppose if A related to B and B related to C, we want to show that A related to we want to check whether A related to C. Now, since A related to B implies A minus B is even, and so we assume here A minus B is equal to 2 times K1 for some K1 belongs to Z. Similarly, B related to C implies B minus C is even, and this implies B minus C is equal to 2 times K2 for some K2 belongs to Z. Now, we want to check whether A and C is even. So, consider A minus C. This A minus C can be written as A minus B plus B minus C. So, we add and subtract minus B, okay. So, this implies, but we know that what is the value of A minus B? A minus B is 2 K1 and B minus C is 2 K2. So, this is equal to 2 times K1 plus K2, Okay, this implies since k1 k2 are integer, k1 plus k2 is also an integer, and therefore this implies a minus c is equal to 2k3, where k3 is equal to k1 plus k2, and therefore this implies, okay, a minus c is an even integer, but this implies, okay, this implies a minus c, this implies a related to c, and therefore r is an, this implies r is transitive relation. Now you can see here r is reflexive as well as symmetric and transitive, and therefore this implies r is an equivalence relation. Now we want to determine distinct equivalence classes. Now first we want to determine what is an equivalence class of 0. So we know that what is a definition of equivalence class. If you want to determine equivalence class of A, then it is a collection of all B belongs to R such that all B belongs to R such that A related to B. Want to collect all B such that A related to B. Now here one correction. We want to collect B such that A related to B. So here if you want to find a equivalence class of 0, then all even integers, that is minus 4, minus 2, 0, 2, 4, 6, they are all related to 0, because their difference is always difference of these numbers. Difference of these numbers with 0 is always even integers. Now if you determine equivalence class of 1, then you can see here the difference of minus 5 minus 1 is even, minus 3 and 1 is even, then minus 1, 1, 3, 5, 7, these all integers are related to 1, because we know that what is 7 minus 1, which is a 6 and which is a even. Similarly, what is minus 3 minus 1, which is minus 4 and which is also an even integer. So all these integers are related to 1, and therefore these numbers lies in equivalence class of 1. Similarly, you can determine equivalence class of 2, which is also again it is minus 4, minus 2, 0, 2, 4, 6 and so on. And similarly, the equivalence class of 3 is equal to minus 5, minus 3, minus 1, 1, 3, 5, 7, and you can see here the equivalence class of 2 which is same as 0, equivalence class of 1 which is same as 3, and therefore there are only two distinct equivalence classes, 0 and 1, only two distinct equivalence classes. Thank you.